Hi there, welcome to lecture video part 1 for chapter 17, AP Environmental Science. This is our chapter where we're going to talk about air pollution, weather. This is the chapter that will eventually lead into chapter 18, which will discuss climate. All right, so let's begin. Let's talk about chapter 17. Chapter 17 begins by talking about the atmosphere that we live in. Earth has air around it. You can even see clouds on here. This atmosphere that we have around us is pretty awesome. It enables us to live on Earth. Without this atmosphere that we have, we probably would have a very cold Earth. It would be extremely warm at times and dangerously full of radiation if the atmosphere wasn't there. It would be very cold. It would be a dangerous place for us. Life couldn't make it here as we know it without an atmosphere. Our atmosphere gives us our oxygen, it shields us, protects us, and it is all the air that's around us. It doesn't seem like air has weight, but the air in our atmosphere has mass. It has some weight to it, which causes what's called air pressure. So the more air pressure you have, the more air you have pushing down on you. So almost think of it as like the weight or the air pressing down on you as air pressure. Low pressure means you don't have as much air pressing down on you in comparison to another area. This shows you the layers we're going to talk about: the troposphere, the stratosphere, the mesosphere, the thermosphere, and even beyond that in the exosphere. We're going to talk about that also. This is a graph that shows you trends: altitude, temperature, ozone concentration. Ozone is right here, this blue line. Okay. And you'll notice ozone concentrations right at the ground. There is ozone at the ground, and this is ground level ozone. This is not good for us. Ozone in the air that we are breathing, not good for us. Okay. Not good for us at all. Ozone up here in this area called the stratosphere. This is the ozone layer. This is the one that protects us. So we enter the troposphere. As you go up in the troposphere, it gets colder and colder. As you go up in the stratosphere, it gets warmer and warmer. I'll explain to you why that happens. The mesosphere, then it gets cooler again, and then thermo, the heat one, it gets warm again. Where it gets warm has to do with the absorption of radiation and energy coming from the sun. Certain particles, certain types of air molecules will absorb more radiation. Therefore, that area may get warmer, even though you would think it should be getting colder. It has to do with the absorption of the sun's radiation. So let's talk about the layers. The troposphere, all right? The troposphere. Now, your book says there's 4 layers, and we're going to go with 4 layers, but I've added a layer because you'll see it in quite a few pictures. Beyond the thermosphere is the exosphere. All right, so your book, 4 layers, but it really has sort of a 5th layer. The troposphere, this is the bottom layer. This is us. This is where you have weather. This is the air that we breathe. Most of the weight or the mass of the atmosphere is here. Think about it. This is where the air is pressing down on you the most. There's more air particles. As people go up a mountain, they have a harder time breathing. That's because there's less air. So the lower you go in the troposphere, the more air mass you're going to have and you're going to feel. So you go up a mountain, less air, less air, less air, harder to breathe oxygen, and you have less of it in the air. Right? As you go up, air gets cooler. All right, gets to the point of negative 52 degrees Celsius. Planes, they fly at towards the top of it, right around 10 kilometers, about 6.5 miles above sea level. 6.5, 6.6 is about 10 kilometers. Planes are flying, that's their cruising altitude, is right about that point right there. Okay. Stratosphere, the next layer after the troposphere. Well, look, this layer gets warmer and warmer and warmer and warmer. Well, why? That's because the ozone layer that is located in the stratosphere is absorbing a lot of the stuff called UVB radiation, not UVA. A lot of the UVA gets through, but the one that we need to worry about, the cancer causer, UVB. Okay, this is the one that we got to worry about. So, what does the ozone layer do? Ozone, which is O3, absorbs a lot of it, which is why the temperature increases in that layer. The ozone absorbs it, some makes it through, causes skin cancer, sunburns, things of that sort. But without the ozone layer, a lot more would get through, and we'd have a lot more problems with skin cancer and things of that sort. An eye disease you can also get from ultraviolet light exposures, cataracts, common eye disease that results from UV exposure. The mesosphere, that comes next. So look at this picture. You have the strato down here, weather, planes are at the top of it. You have the ozone layer sitting in the stratosphere. Some supersonic planes are up there, or jets are up there. Then you get up here to the mesosphere. Okay, very low air pressure. You just don't have a lot of air particles up there. And that's because it's so far above sea level. You're talking about almost 50 to 80, 30 to 56 miles above sea level. Very high, very little air. You would not be able to breathe up there. None of us would be able to breathe up there. We would be struggling for air in the stratosphere and even at the top of the troposphere anyway. We'd be struggling at air as we go up. Our bodies are not used to having such little quantity of oxygen in them. Meteors, they burn up. See these meteor showers? You'll see them in the mesosphere. Okay, that's where you'll see them. See these aurora borealis type of stuff. You're seeing this in the mesosphere. Okay, as you go up in this one, the mesosphere, it starts to get colder again. Okay, it starts to get colder. The thermo heat. Well, it's not. If you were to enter the thermosphere, you're not going to think it's very hot actually, even though it's called the thermosphere. The particles, the temperature there of the particles will be warmer. Yes, but would you actually feel it if you can actually feel it? No, because very little air would be touching your body, so that you wouldn't have that much heat touching you as a result of very few air particles. Very low air pressure there, and the temperature does get cold. Excuse me, the temperature increases with altitude through the thermosphere. Outer point of the thermosphere, you have the exosphere. You have in the thermo and the expo, this is where you're going to have some space travel, some things of that sort. You have up here in the thermo, you have satellites orbiting the Earth, and all that stuff is taking place there. So these are the layers of the atmosphere. All right. So now let's talk about things that relate to weather, common things. Air pressure, we're going to talk about that in a second and what it does. We already briefly have mentioned it. Humidity, which is the moisture in the air, and of course, how hot or cold an area gets. So air moves, especially in the lower atmosphere. It moves all over the place. What causes air to move? Similar to like we just had a chapter on water, pressure differences, which would be more like concentration differences. In our last chapter, one of our earlier chapters, we talked about the ocean and the ocean water. You'd have a higher concentration of salts, for example, things of that sort. But we're not dealing with that. Different thing. We're not talking about dissolved items. So we're talking about air pressure. All right, that makes air move, and we'll talk about that in more detail in a second. Density, how heavy or light the air is that cause it to move up or down, vertical movement. Relative humidity, how much moisture is in it, because moisture determines the kind of weather you're going to have. And temperature relates to a little bit of all of the other ones. Gravity, all right, it pulls air towards Earth, right? And that's what causes this air pressure. At lower altitudes, where it's lower, like if you're climbing a mountain, you're going to have more air at the bottom of a mountain than at the top of the mountain. Okay. Atmospheric pressure. So this is air pressure. As you go up, less air above you. It decreases with altitude. Right? Air commonly moves from an area of high pressure to an area of low pressure. I'm going to show you some pictures in a second. Okay. So let's first talk about relative humidity here. This has to do with moisture in the air. If it's relative humidity is low, you're not going to get rain probably in an area. You just can't. There's nothing that's going to fall from the air. So humidity generally on the weather channels will tell you whether there's probably a good chance of rain falling or not. We may have a very humid day and a warm day. Yeah, we might have a tropical storm or a tropical shower that particular day. Basically, we feel warmer when it's humid out. Your body feels warmer, so you'd sweat more. So, like if you go somewhere like Florida or Texas in the summertime, and your body sweats. When you sweat, your body tries to cool itself down by allowing the water to evaporate. When the water evaporates, the sensation left behind is a cooling sensation, which is how we cool our bodies. Evaporative cooling is what it's called. Well, when it's very humid in the air and you sweat, the sweat doesn't evaporate. It stays on your body, and you actually get warmer as a result of that, and you feel warmer. And what does your body do? Then sweat some more to cool itself down, and now you're even more wet and sweatier, and then it doesn't evaporate from your body when it's very humid, and it's a positive feedback loop. You just sweat more, and then you get warmer, and you sweat more, and you get warmer, and it doesn't evaporate. So you keep adding water or sweat to the outside of your body, and your body is not cooling. That's how humidity really affects the way we feel. Temperature measures the motion of particles and how quickly things are moving. Moving faster, warmer. All right. So temperature around the world has a lot to do with the angle at which the sun hits those areas. We have seasons as a result of this. Right? Sun hits the earth at different locations at different angles, and that's what creates these seasons all around the earth. Land surfaces, they heat up quicker than bodies of water. And why? Because they have a low heat capacity. Water has a high heat capacity. It can absorb a lot of heat or a lot of energy before it actually changes temperature. Where land doesn't, it will change temperature much quicker, much easier. So here's what happens. As the sun starts to shine, the ground heats up. When the ground heats up, the air will now rise. Rising air would lead to low air pressure. It's not pressing down, it's rising, low air pressure. And then that low air pressure would have an effect on the area regarding weather and what you would expect. Solar energy, this heats the atmosphere, helps create seasons. Well, what does solar energy do? Well, sunlight, I already mentioned you, hits the earth a second ago. At the equator, it's more direct, which means the equator has a warm weather generally all year. Us here in North America, when we're hit at an angle like this, see this angle we're being hit at? This would be more like our winter time. Okay. When you're hit more direct, that's when it is your summertime. So in our summertime, we're going to be getting hit more like this. In our wintertime, we're going to be hit at an angle. Okay. This angle means these photons of light are spread over more space. Because they're spread over more space, they have less effect, or the energy is spread over less space, so it won't heat up the area as much. So this would be winter, where in this case, the photons of light, their energy is spread over smaller amount of space, therefore they're more concentrated, and you'd have a bigger effect from the sun hitting you. With a direct ray, you're going to get sunburn more likely from direct rays than you are from indirect rays. All right. So how intense the sun is has a lot to do with the angle at which it hits us. Well, why is it angled? Because the Earth is tilted 23.5 degrees. So since the Earth is tilted 23.5 degrees, we have seasons on the Earth. So the seasons are dictated by this tilt. When we are in the north are being hit by direct rays, we are in summer. When we are being hit by indirect rays, so us in this case, right? See us here, this is us tilted. The north is tilted towards the sun. This is our summer. The north is tilted away from the sun. This is our winter. This picture doesn't do justice. During our summer, we are actually farther from the sun. During our winter, we are actually closer to the sun. Okay. Farther from the sun in our summer, closer to the sun in our winter. So proximity does have an effect a little bit on temperature, but the angle of the sun has a bigger factor. Direct rays will heat up the earth even though it's farther from the sun during our summertime. Okay. So the angle at which you're getting hit is really the factor on how warm an area is going to be. Direct rays, warmer, summertime. Indirect rays, wintertime. Convective circulation. So what does air do? Well, air moves. Okay, so air moves in a circulation type of pattern. What does that mean? Well, a lot of you have convection ovens. That means you have air that circulates in a circular manner. So what happens? All right, let's look at this. All right. Cold air. It's dry. Okay, cold, dry. It's heavy. It's heavy air. This cold air is heavy. It will sink. Okay, it sinks. As it sinks, this warmer air will begin to rise. Okay, you notice how it's dry here, this warm air? That's because it was originally cooler air that fell. Cooler air is drier air. So it falls and then it starts to get warm as it picks up heat or sunlight. The ground below it gets warm and then the air starts to rise. As the ground gets heated, water evaporates. So now this hot, moist air starts to rise. Okay. As it rises, you might get condensation, precipitation, and then back again, that cooler air will start to sink. It creates a convection current. Cold air sinks, warm air rises, and it creates a current. Your convection oven does this. You have a fan in the back, it blows the air. Why does it work so well? It cooks your food more thoroughly because the circulation of air gets to the food better, and the food overall will cook faster and more efficiently due to the convection oven. All right. So warm air rises, cold air sinks. All right. So rising air, in case you don't know, is less air pressure. Sinking air is high air pressure. Okay. So weather and climate, what do they have to do? Well, weather is what you expect to happen in an area. Okay. Excuse me, climate, sorry, I screwed that up. Climate is what you would expect to happen. Like, for example, San Diego gets rain sometimes. Sometimes. Would you expect rain in San Diego? No. San Diego's climate is generally sunny, but we do have short-term issues with rain, and rain would be in the weather forecast, but generally not in the climate forecast. All right. So San Diego's climate, about 70, 75 and sunny most of the year. We may experience weather occurrences that don't match with climate, but that's absolutely normal. So you have masses of air that move. Okay. So you have these masses of air that move. Let me move myself out of the way here so you can see these pictures. All right. So we have masses of air that move. You have a front. All right. This is the boundary between two air masses. Okay. So there's a boundary between air masses. There's two kinds, a warm front and a cold front. Well, in a warm front, warm air is going to be moving in and starting to replace this cooler air. All right. Look at this picture. As the warm air moves in, this warm air, as it rises, all right, you might get some light precipitation as a result of a warm front. Okay. So the warm air is moving in. It's going to start displacing this cooler air, moving it out of the way, and you may get a light rainstorm. So if we have a warm front hitting San Diego, we probably will get a lighter rainstorm as a result of it. Okay. Cold front, a little different. This cold, heavier air moves in. Okay, it moves in, it starts to replace that warm air, pushes these clouds up, right? And you then may get heavy, heavy rainstorms as a result of a cold front. So if San Diego has thunderstorms and heavy rainstorms, and we do get that once in a while, then we're probably going through what's called a cold front is coming through. If we have a rain and it is involving lighter precipitation, we generally probably have a warm front that has happened or come through. Now, I've been talking about this whole time about air pressure. Let's talk about it some more. High pressure, usually air sinking. It's pushing down. Air is pushing down. And what does it do as it pushes down? It pushes in every direction away from a high pressure. So areas that have high pressure systems push clouds away from them. Since they push the clouds away from them, sunny, beautiful weather. San Diego, and it'll come up in another, maybe later in this chapter, I believe, or our next chapter, I'll tell you why San Diego has such nice weather. And one of the main reasons has to do with San Diego sits in a place on the earth where we get a lot of high pressure. So we have a lot of sinking air that is pushing clouds away from us. What do we get? Sunny, nice weather as a result of it. Areas like Seattle up north, they get a lot of low pressure systems. They have air that's rising. Rising air is low pressure. And in an area of low pressure, the clouds end up there. And these are the areas that are going to have the precipitation. How does this have to do with what we're talking about here? Well, let's talk about it. Land heats up very quickly, so the air will then rise. You'll get a low pressure system there. Over the ocean, the water does not heat up very quickly, so you have a higher pressure there, and then you have a lower pressure. So as the day proceeds, if you go to the beach, you'll probably notice these winds that start blowing as the day gets warmer and warmer. So if you're a surfer, you generally want to surf in the morning before the sun has come out, or early where the sun hasn't affected things, and you have less wind, cleaner waves to surf. If you wait as the day progresses, like you try to go surf at the middle of the day at noon, you have all the sun beating down on the land is getting warm, you're getting low pressure there, winds start moving, and the surf gets blown everywhere, and it's not that easy to catch as a result of those winds that pick up. So air moves from high to low. Clouds move from high to low. Low pressure is where you're going to have storms and clouds. High pressure is where you're going to have clear, beautiful skies. Now, here's the end of this lecture talking about what's called a thermal inversion. So as normal conditions, as you go up, it gets colder. Okay, that's what happens in the troposphere. As you go up, it gets colder. And when pollutants are released, there's this thing, you need to know this term. It's called vertical mixing. It means these pollutants start mixing with the atmosphere and they start diffusing in every direction. When they move in every direction, the pollutants are not all stuck in one place. I guess we're sharing the wealth with everybody when we have vertical mixing. So as the day progresses, that's what it leads to. The ground gets hot, things heat up, things start to rise as a result of the ground getting warmer. All right, so this commonly happens in a city or in an area where you have a valley. Area gets heated up, and then this air starts to rise, and you have a vertical mixing. You have all these pollutants mixing everywhere. Well, a thermal inversion, and remember, this is normal conditions. In a thermal inversion, what happens is things get flip flopped. Cold air gets trapped below warm air. So there's a flip flopping effect of this area. Cold air gets trapped below this warm air. Because this cold air gets trapped here, as these pollutants rise, they get stuck in lower parts of the atmosphere. And this pollution is then inhaled by the people that are in these lower parts of the atmosphere. So during a thermal inversion, you may be hit by, during a thermal inversion, you're going to have more pollutants in the air. So just breathing in a city during a thermal inversion is not very good for you. And this commonly happens in areas that have valleys, nearby mountains where sunlight is blocked. You have cooler shadowed areas. You have all this stuff coming into play. Why is this a problem, thermal inversions? Well, because you have pollutants trapped near the ground where people are now inhaling them. Right. We're going to stop there today.